Hi children, welcome back to the session. Dear children, in the previous sessions we have learnt the dot product of two vectors, its properties and some problems based on the dot product of two vectors. Dear children, in this session we shall learn the vector product of two vectors and its properties. If A bar and B bar are any two non-zero vectors, if A bar and B bar are any two non-zero vectors, if theta is the angle between A bar and B bar, then the cross product of A bar and B bar is denoted as A bar cross B bar. Just read it as A bar cross B bar, and it is defined as the product of magnitudes of A bar and B bar and sine of angle between A bar and B bar and unit vector n cap which is perpendicular to both A bar and B bar. Again, the cross product of two vectors A bar and B bar is denoted as A bar cross B bar, and it is defined as the product of magnitudes of A bar and B bar and sine of angle between this A bar and B bar and the unit vector n cap which is perpendicular to both A bar and B bar. So this is the unit vector which is denoted as n cap, which is perpendicular to A bar and B bar. That means this vector will be like this, which is perpendicular to both A bar and B bar, right? So usually, this cross product is also known as vector product. This cross product is also known as vector product. It is usually symbolically represented as, that is, A bar cross B bar is equal to magnitude of A bar into magnitude of B bar into sine theta into n cap. Here where theta is the angle between A bar and B bar and n cap is the unit vector perpendicular to A bar and B bar. Theta is the angle between A bar and B bar. Okay, so simple definition, we have the cross product or vector product of two vectors is denoted as A bar cross B bar, and it is defined as the product of magnitudes of A bar and B bar and sine theta and n cap which is perpendicular to both A bar and B bar. Usually symbolically it is written as A bar cross B bar is equals to magnitude of A bar into magnitude of B bar into sine theta into n cap. So n cap is the unit vector perpendicular to both A bar and B bar. Next we have properties of cross product or vector product. So we have A bar cross B bar is a vector. The cross product of any two vectors gives the vector itself. Again, number 2, we have A bar cross B bar is equals to minus B bar cross A bar, B bar cross A bar. That is, so cross product is anti-commutative. That means, if you interchange the two vectors, then sign of that will change. Okay, that means A bar cross B bar is equal to minus B bar cross A bar. I have just interchanged the vectors A to B, B to A. Therefore, we have minus B bar cross A bar. For example, if A bar cross C bar, this can be written as minus C bar cross A bar. Just interchange the vectors, then sign of that changes. Okay. Next, we have third one. That is, we have symbolical representation of cross product of two vectors. That is, A bar cross B bar is equal to magnitude of A bar into magnitude of B bar into sin theta into n cap. Okay, so here apply magnitude on both sides. Therefore, magnitude of A bar cross B bar is equals to magnitude of A bar into magnitude of B bar into sin theta into magnitude of unit vector gives what? 1. Okay, just remember this. The magnitude of unit vector is what? 1. Again, therefore, what is sin theta? That is, sin theta is equal to magnitude of A bar cross B bar whole divided by magnitude of A bar into magnitude of B bar. So, this is sine of angle. Therefore, the sine of angle between A bar and B bar is given by magnitude of A bar cross B bar divided by magnitude of A bar into magnitude of B bar. Therefore, theta angle is equals to sine inverse of have A magnitude of A bar cross B bar divided by magnitude of A bar into magnitude of B bar. Okay, you should remember this. That is, sine of angle or theta angle is given by sine inverse of magnitude of A bar cross B bar divided by magnitude of A bar into magnitude of B bar. Next we have, so that is A bar cross B bar is equal to 0. If A bar cross B bar is equal to 0, this indicates that A bar and B bar are parallel to each other. Therefore, the vectors will be like this. A bar will be like this and B bar overlaps on that. So, therefore, that is, if A bar cross B bar is equal to 0, then A bar and B bar are parallel to each other. Or if A bar and B bar are parallel to each other, then their cross product will be equal to 0. Next, we have, so that is I cross I is equal to J cross J is equals to, we have K cross K is equal to 0. I cross I is equal to J cross J is equal to K cross K is equal to what? 0. That means the cross product of similar vectors gives what? A 0. Remember, in dot product we had I dot I is equal to J dot J is equal to K dot K is equal to, we have 1. But here in cross product, I dot I cross I is equal to J cross J is equal to K cross K is equal to what? 0. Next we have, so just Next property we have sixth one, that is I cross j. I cross j is equals to we have k. Similarly, so j cross k, that is j cross k is equal to I. Similarly, we have k cross I is equal to j. Again, children, remember anti-clockwise. We have anti-clockwise, that is I cross j is equals to k. J cross k is equal to I. Again, k cross I is equals to j. Right? Next, we have next property. So that is in clockwise direction, that is I cross k. I cross k is equal to minus j. Children, again I cross k is equals to minus j, just in the clockwise direction. Okay. Similarly, we have k cross j is equal to minus I. Similarly, we have j cross I is equal to minus k. Minus k. Just remember this figure. Here we have the anti-clockwise direction, I, j, k. So that we have I cross j is equal to k. Again, j cross k is equal to I. Then k cross I is equal to j. When you come in clockwise direction, we have I cross k is equal to minus j. K cross j is equal to minus I. J cross I is equal to minus k. Minus k. You should also remember this. Okay. So you should remember this properties well. Okay. Again, so that is a bar cross b bar is vector. The product of cross product of two vectors is always a vector. So a bar cross b bar is equal to minus b bar cross a bar. That is, when you interchange two vectors, then sign of that changes. Again, we have sin theta is equals to magnitude of a bar cross b bar divided by magnitude of a bar into magnitude of b bar. Next, if a bar cross b bar is equal to 0, then this indicates the two vectors are parallel to each other. Then I cross I is equal to j cross j is equals to k cross k is equals to we have 0. Next, remember this also. Next, we have cross product of two vectors in terms of components. That is, if the components are given, then how to find the cross product of two vectors? Let a bar is equals to x1i plus y1j plus z1k, and b bar is equals to x2i plus y2j plus z2k. Then the cross product, that is a bar cross b bar is equal to determinant of. So we have already learnt determinants in determinant chapter. Next, that is I, j, k. First, write the scalar component of first vector. That is, we have a scalar component, that is x1, y1, z1. Next, write the scalar component of the second vector, that is vector b, that is x2, y2, z2. So this is how to find a cross product of two vectors in terms of components. We know how to expand this. So expand this and convert this into 2 by 2 determinant. 2 by 2 determinant. We'll solve some examples, then you can easily understand this. For example, if a bar is equals to I plus j plus k, and b bar is equals to I minus 2j minus k, then a bar cross b bar is equal to determinant of I, j, k. Write the component of a bar, that is scalar components of a bar, that is here 1, we have 1, then 1, Here next write the scalar components of b vector, that is here we have 1 minus 2 minus 1. Okay, again expand this, again that is equals to I into determinant of converting a 3 by 3 determinant in terms of second order determinant, that is I into leaving this entire row and column, write the remaining elements in a determinant form, that is I of 1 1 minus 2 minus 1, again minus j into determinant of leaving this entire column and row, write the remaining elements, that is 1 1 1 minus 1, we have 1 1 1 minus 1, again plus k into determinant of leaving this entire column and row, we have 1 1 1 minus 2 1 1 1 minus 2. Okay, so now we know how to expand this, that is equals to I of product of principal diagonals minus product of non-principal diagonals. So that is 1 into minus 1, we have minus 1, again minus 2 into 1, we have minus 2, minus of minus becomes plus 2, again minus j of, again product of principal diagonals minus product of non-principal diagonals. 1 into minus 1, we have minus 1, minus 1 into 1, we have 1, again plus k into 1 into minus 2, we have minus 2, again minus 1 into 1, we have 1. Okay, simplification, that is equals to minus 1 plus 2, we have 1, 1 into I, that is I, again see here minus 1 minus 1, we have minus 2, minus 2 into minus j, we have plus 2j, again minus 2 minus 1, we have minus 3, minus 3 into plus k, we have minus 3k, minus 3k. So this is the cross product of a bar and b bar. See here, cross product of any two vectors gives again what? The vector itself, whereas in the previous, that is the dot product of two vectors gives a scalar, but whereas in cross product of two vectors gives the vector itself. Okay, next we have a unit vector. So unit vector perpendicular to a bar and b bar, so that is n cap. If a is a bar and this is a b bar, if theta is the angle, then a unit vector perpendicular to both a bar and b bar, both a bar and b bar is given by n cap is equals to we have a bar cross b bar, a bar cross b bar divided by magnitude of a bar cross b bar. Okay, again remember, the unit vector perpendicular to a bar and b bar, unit vector perpendicular to both a bar and b bar is given by n cap is equal to a bar cross b bar divided by magnitude of a bar cross b bar, a bar cross b bar. Okay, next we have geometrical meaning of cross product of two vectors. Geometrical meaning of cross product of two vectors. First we have area of a parallelogram. If a bar and b bar are the adjacent sides of a parallelogram, or if a bar and b bar represents the adjacent sides of a parallelogram, then the area of the parallelogram is given by, that is determinant of a bar cross b bar, Remember, if A bar and B bar are represented by adjacent sides of a parallelogram, then the area of the parallelogram is given by magnitude of A bar cross B bar, A bar cross B bar. If A bar and B bar, or we say D1 bar or D2 bar, D1 bar and D2 bar. If D1 bar and D2 bar represents the diagonals, so this is diagonal. If D1 bar and D2 bar represents the diagonals of a parallelogram, then the area is given by 1 by 2 into D1 bar cross D2 bar, D1 bar cross D2 bar. Again, if D1 bar and D2 bar represent the diagonals of a parallelogram, then area of a parallelogram is given by 1 by 2 into D1 bar cross D2 bar. But remember, this is not in our syllabus. We have only area of a parallelogram when two sides or two adjacent sides are given. Next, we have area of a triangle. Area of a triangle. Again here, if A bar and B bar, A bar and B bar represents the adjacent sides, either this or if A bar and this is B bar. If A bar and B bar represents the adjacent sides of a triangle, then the area of a triangle is given by A is equals to, we have 1 by 2 into magnitude of A bar cross B bar, magnitude of A bar cross B bar. So remember, if A bar and B bar are adjacent sides of a triangle, then the area A is given by 1 by 2 into magnitude of A bar cross B bar. This here we have other. If A, B and C are the vertices of a triangle, so that is vertices A, B, C. If A comma B comma and C are vertices of a triangle, or if the position vectors are given, if the position vectors are given, then the area A of a triangle is given by A is equals to 1 by 2 into magnitude of, we have AB bar cross AC bar, AB bar cross AC bar, AB bar cross AC bar. Again remember here, if A, B and C are vertices or position vectors of a given, position vectors are given, then how to find the area of a triangle? That is A is equal to 1 by 2 into magnitude of AB bar cross AC bar. Okay, you should remember this. Whenever the two adjacent sides are given, use this formula. Whenever the position vectors are vertices are given, use this formula to find the area of a triangle. Okay. Now we will solve some problems based on the concepts. Here we have, if A bar is equal to 2i plus j plus 3k and B bar is equal to 3i plus 5j minus 2k, find magnitude of A bar cross B bar. So first of all we have to find cross product of two vectors, that is here given. A bar is equal to 2i plus j plus 3k and B bar is equals to, we have 3i plus 5j minus 2k. So we need to find cross product of two vectors first, then we need to find magnitude of that. Therefore A bar cross B bar is equal to determinant of I, j, k. Write the scalar component of the a bar, that is we have 2 1 3. Then write the scalar components of vector b, that is we have 3 5 minus 2 minus 2. Again expansion, expanding by first row, again that is equals to we have I into determinant of leaving this entire row and column, deleting the entire row and column, we have 1 3 5 minus 2, again minus j into determinant of deleting this entire column and row, we have 2 3 3 minus 2, again plus k into determinant of deleting the entire row and this column, we have that is 2 1 3 5. Now expanding this, that is equals to we have I of product of principal diagonals minus product of non-principal diagonal elements. 1 into minus 2, we have minus 2, again minus 5 into 3, we have 15, again minus j of 2 into minus 2 minus 4, again minus we have 3 into 3, that is we have 9, again plus k of 5 into 2, we have 10, minus 3 into 1, we have 3. Now simplification, again that is equals to minus 2 minus 15, we have minus 17i, here minus 4 minus 9 minus 13, so minus 13 of minus, that is plus 13j, again we have plus 10 minus 3, that is we have 7 into k plus 7k. So this is a bar cross b bar, a bar cross b bar, but we need to find magnitude of a bar cross b bar. Therefore apply magnitude for this, therefore that is magnitude of a bar cross b bar is equal to, we have formula square root of here x square plus y square plus z square, right? Again here what is the value of x? Compare this with standard equation, that is xi plus yj plus zk. What is the value of x? Minus 17. So minus 17, that is equal to square root of, we have minus 17 whole square, we have 289. Again plus y, what is the value of y? 13. So 13 whole square, we have 169. Again so z value, we have 7 whole square, we have 49. Again that is equal to square root of 289 plus 169 plus 49, we have 507. Therefore this is the value of magnitude of a bar cross b bar. Next we have find the unit vector perpendicular to both a bar and b bar, where a bar is equal to 4i plus 3j plus 2k and b bar is equal to I minus j plus 3k. So we have formula for that. So unit vector perpendicular to two vectors is given by n cap is equal to a bar cross b bar divided by magnitude of a bar cross b bar. A unit vector perpendicular to both a bar and b bar is given by n cap is equal to a bar cross b bar divided by magnitude of a bar cross b bar, whereas n cap is equal to a bar divided by magnitude of a bar. So this is a unit vector in the direction of a given vector, So n cap perpendicular to both a bar and b bar, here in the direction of a bar. Okay, you should remember this too. Okay, so now we have this one. Then therefore we need to find A bar cross B bar. So therefore, so A bar cross B bar is equal to determinant of, we have I, J, K. Scalar component of A bar, that is 4, we have 3, then 2. Scalar component of vector B, we have 1, here we have minus 1, then we have 3, right? Expansion, that is equal to, we have I into determinant of deleting this entire row and column, we have 3, 2, minus 1, 3. Again minus J of deleting entire row and this column, we have 4, 2, 1, 3. Again plus K of deleting entire this row and column, we have 4, 3, 1, minus 1. Simplification, that is equals to, we have 3 into 3, 9, minus 1 into 2, we have minus 2, minus of minus, we have plus 2 of I. Again we have here, that is minus 4 into 3, 12, minus 1 into 2, we have 2 of J. Again plus 4 into minus 1, we have minus 4, minus 3 into 1, we have 3 of K. Again simplification, that is equals to 9 plus 2, 11 I, minus we have 12 minus 2, 10, 10 into I, J, that is 10J. Again we have minus 4, minus 3, minus 7, minus 7K, minus 7K. Therefore magnitude of A bar cross B bar is equal to square root of, we have 11 square 121, 11 square 121, plus we have 100, 10 square 100, then 7 square minus 7 whole square, we have 49, again that is equal to 270. Okay, so this is magnitude of A bar cross B bar. So therefore n cap is equals to A bar cross B bar divided by magnitude of A bar cross B bar. Again that is equal to, what is the value of A bar cross B bar? We have that is 11 I minus 10J minus 10J. Again we have minus 7K all divided by magnitude of A bar cross B bar is root 270. Again that is equals to 11 divided by root 270 into I minus 10 divided by root 270 into J. Again minus 7 divided by root 270 into K. So this is the unit vector which is perpendicular to A bar and. Next we have find the unit vector perpendicular to both A bar and B bar, where A bar is equal to 3I plus J minus 2K and B bar is equal to 2I plus 3J minus K. So we need to find A bar cross B bar. Therefore A bar cross B bar is equal to determinant of I, J, K. Component of scalar component of A bar, we have 3, 1, minus 2. Scalar components of vector B, that is 2, 3, minus 1. Again simplification, that is equals to I into determinant of leaving this entire row and column, we have 1, minus 2, 3, minus 1, minus J into determinant of leaving this entire column and row 3, minus 2, 2, minus 1. Again plus K in determinant of, we have 3, 1, 2, 3. Simplification, that is equals to, we have 1 minus 1, minus 1. Again minus 3 into minus 2 minus 6 minus I minus plus 6 again into I minus 3 into minus 1 we have minus 3 again minus 2 into minus 2 we have minus 4 minus of minus plus 4 into j again plus we have 3 into 3 9 minus 2 into 1 we have 2 again into k. Now simplification, that is equals to minus 1 plus 6 we have 5i. So we have minus 3 plus 4 we have 1j, that is minus j plus we have 9 minus 2 7 into k we have plus 7k. Now again magnitude of a bar cross b bar is equal to square root of we have 5 square 25 minus 1 whole square we have 1 plus 7 square we have 49 again that is equal to root 75. Therefore n cap is equals to a bar cross b bar divided by magnitude of a bar cross b bar. So this is how to find the unit vector perpendicular to both a bar and b bar. Again that is equal to we have a bar cross b bar, that is 5i minus j plus 7k all divided by root 75 or that can be written as 5 divided by root 75 into I minus 1 divided by root 75j again plus 7 divided by root 75k